Now the next category, with argument, without return. Now with argument means what? Now the calling function passes some values with a function call. See now. Here your execution starts with a main function. We declare two variables, int a and b. We accept that two values a and b. Suppose a is equal to 1, b is equal to 2. Okay. Now this a and b is called as actual parameters. This called as a actual parameters. Okay. So which are the actual parameters? This a and b are the actual parameter, and we'll initialize a with 1, b is with 2. So for this, in a memory cell, I initialize actual parameter with 1 and 2. Okay. Now with this function call, I'll send the value of a and b, that is 1 and 2. So whenever we detect the function call, control hand over to your calling function add. Okay. Now here if you observe, we send two values 1 and 2. Of which data type? Integer data type. Now to receive that, we require extra two variables with the function call, that is called as a dummy parameters. So this a and b are the dummy parameters. Okay, so this one value is received by your a value. So this a is initialized with what? 1. This b is received by this b value. So this b is initialized with which value? 2 value. So if I'll draw this diagram, if you observe here, the actual a value is 1, that is received by dummy parameter a, and initialize that with the same 1. Similarly, the actual parameter b is received by dummy parameter b and initialized with value 2. Okay, so suppose anyone wants to change this name. So instead of a and b, if I want to change this name to suppose d and e instead of a and b. So this is what? This is your d, this is your d, and this is your e. This is perfectly okay. If you observe, if I'll keep the same name a and b, okay, and if you concentrate on this memory, the memory assigned for this a actual parameter is 1000. Memory assigned for this b parameter is 2000. Okay, so this a and b or actual parameters are the local variables for your main function. Okay, now these values you are sending to dummy parameter, and instead of d, if I'll keep this a as it is. Okay, so this a is what? A dummy parameter, and the memory assigned for this is 3000. So this a is different, this a is different. This b is value, this b is assigned with value 2, and memory assigned for that is 2000. Now we are just passing this b value to another b variable, which is stored at memory location 4000. So this a is different, this a is different, this b is different, this b is different. Okay, So whenever we call any function with two values or two variables, these are called as the actual parameters. These actual parameters are sent, then this value is received by dummy parameter, another dummy parameter with the same data type. Similarly, if you send another value or another variable, for receiving that you require one more extra variable of the same data type. That means if this is integer, compulsory this would be your integer. See. Okay. Now I'll come back. This is A, this is again B. Okay. And now I want to perform the addition of these two variables. I'll take one more extra variable C. So now this is my C variable. Here I assume a memory 5000. Now this is a dummy parameter? No. This is what? A local variable of add function. Okay. Keep that. That is, this dummy parameter is different. This local variable, that means the scope of this C variable is limited up to this parenthesis. Okay. So here I declare one more variable C, and the addition of this A and B, that means 1 plus 2 is stored in C variable. So this C is now initialized with which value? 3. Okay, and immediately here I display the result, that is C is 3. So we display the result, and after performing this task we come back to our calling functions next line, and next line would be your end of your main function, and that is what? It just stop. Okay, so I'll just draw the diagram. This is A and this is B. Assume a memory for this is 1000, memory for this is 2000. Okay, with this add function I am sending A and B, which we initialize with 1 and 2. Okay, so whenever we call any function by passing A and B, these are called as actual parameters. Okay, so after this we'll come to the definition of a function, and in a definition I'll write add, and now I want to receive this. So which value? I'll send integer value. To receive that I require next integer value. So here you can give another name or the same name, it's your choice. It's just a dummy parameter. So I write here A. So A is what? 1. So I am sending this one value with this. Now this dummy parameter A is initialized with what? 1. So again here I draw a diagram. So this is my next A. Memory initialized for this A variable is, suppose I am considering 3000. Okay. So this A, one value is come here, and now it is initialized with 1. After that, if you observe, after this comma, I am sending the next value. So which value I am sending? Integer value. So to receive that, again I here give a comma, because now I want to accept the second value. So now for receiving this, I'll take one more extra variable of integer data type. That is, you can again give the same name or another name, it's your choice. So now if you observe which value I am sending here, 2 value. So 2 value is sent by actual parameter, it is received by dummy parameter B, and now this B is initialized with value 2. So this is B, this B. Memory initialized for this is 4000, and if you observe here, we are sending this value 2 over here. So these are what? Actual parameters. Okay, and we are saying these are what? A dummy parameters. Okay, so this is difference between actual parameter and a dummy parameter. Okay, now so this is your first style of writing, that is your header file, your main function, and in between we add a definition of user defined function. So if you observe here, the prototype declaration is not return, only a function call and the function definition. Whereas in this B style, if you observe, program starts with your main function. Here we call the function. This is what? A function calling. Function or control handover to your calling function. After performing this task, control handover back to your calling function's next line, and next line is what? It's just a stop. Okay, so in the second style of function writing, we required a prototype declaration, function calling, and function definition. Now the third category, with argument with return. So as we all know, with argument means we are passing the list of parameters or variable with the function call. Okay, so as we all know, the execution starts with your main function. First statement, we declare 3 variables, int a, b and d. I'll tell you why we declare d afterward. After that, we accepted value of a and b from user. So as with the previous, I'll say a1, b2, and after that I call the function add, and here I send 2 integer values a and b. That means a is 1 and b is 2. This is what? A function calling, okay, by passing the 2 values. So it's a with argument. Okay, so whenever we detect a function call, compiler hand over the control to your calling function. So after whenever we detect this, control hand over to your calling function. So now this a is received by a dummy parameter a, and this a is initialized with value 1. Okay, so I'll go here. This is my actual parameter. So this a is received in a dummy parameter a. So this a will write it here. Okay, after that, similarly, this actual parameter value b is 2, and this is received by integer b. So we'll draw this. Now this would be your 2. Okay, now here we declare one local variable c. So now this c is a local variable of add function. Okay, whenever we declare, memory is initialized by compiler. After that, here we perform the addition a plus b and stored in C. So this 1 plus 2 is stored in C, that is nothing but your 3. Okay, and now this is very important. Now we'll write a keyword return, that means return the value C to your calling function. So it's with argument. These are the arguments we are sending, and now with return, that means using keyword return, we are sending value to your calling function. Okay, so as we observe here, whenever we send any value, for receiving that we required another value. Okay, so similarly, whenever we return anything back to your calling function, to receive that you required one extra variable, and so for that receiving we'll take here one extra variable as a d. Okay, so now this C, what is the value of C? C is 3. Now return 3. This value is returned back to your calling function, and now this is received by variable d. Okay, so here the syntax is changed. D is equal to add a comma b. So this indicates that the function returns some specific value which is received in a d variable. Okay, and after this we'll write printf / new line d is equal to %d comma d, and here we display the result d is equal to 3. Okay, so diagrammatically again I'll show here. This is my d variable, some specific memory initialized by that compiler. Now this d is what? This d is a local variable of which function? Main function. Okay, so whenever we return C, that C, that is 3 value, is received by whom? D. So diagrammatically I'll just represent this transition. Now this 3 value is received by whom? D. Okay, and after that we simply display the value d. So this is our third category, with argument with return. That means with this function call we send the arguments, and with this d, whichever value we return will received in d, and after that we display the result of that d. So after these statements, what we detect? This is the end of your main function. So this would be your stop. Okay, so always we know that the execution starts with the main function and it ends with the stop function. Here we discuss only one type of style writing of user defined function, in which we write the function definition after main. Okay, now the most important thing, which value we are returning? C. So C is of which data type? Integer. So return data type of this add function is integer. Okay, so in a definition I'll just add the return data type int, and now this is what? A function calling. This is a function definition, and now one more part is left, that is a prototype declaration. So you can declare it before a function call anywhere, but we'll write here before main function, that is int, then what is the function name? Add, and then which two value we are sending? First integer, comma, second integer. and after that we'll give a semicolon. Okay, so this is what your prototype declaration, this is what your function calling, and this is what your function definition. Prototype declaration, this is function calling, and this is function definition. Now the last category, that is without argument with return. That means now we'll understand that without argument means we are not passing anything in between this parenthesis, round bracket. So without argument, but with return means surely will return some value to your calling function. So let us start. So executions always starts with your main function. After that we detect a function call. So function call means the function or control handler to your calling function. After that we declare 3 variables. We accept 2 values, a and b, that is a would be 1, b would be 2. So similarly I'll draw the diagram. A initialize 1, b is initialized with value 2, and memory we assume that 1000 and 2000. Similarly now c is also there, memory initialized with this is 3000, and now after performing this addition operation result of c is 3. Now this a, b and c are what? These are now local variables of your add function. Okay, and now this c, that is 3, I want to return back to my calling function. So as we know that whenever we send a local value to another function, we require extra variable to receive that. So here I'll write int, suppose d. That means whenever we send or return c value, we receive that in a d. So simply I'll draw here a diagram, d with memory initialization. Okay, and now here I'll make one change, d is equal. Okay, so after this d, now as we know whenever we return this c, to receive that we declare variable d, and we change the syntax of writing or calling the function, that is d is equal to add round bracket. So now this c value, that is 3, we send it to calling function which is received in variable d. So this c is send it and received by d, and which is nothing but your 3. And after that I'll write just printf / new line d is equal to %d d. Okay, and with this I'll change the syntax. Which value you are returning? C. C of which data type? Integer. So you are returning return C, that means you are returning integer value. So here I'll just write return data type as a integer. Okay, and the prototype declaration before main function, that is return data type int, function name add, and you are not passing anything, so it's empty round bracket ends with the semicolon. So what is this? This is your prototype declaration. this is what your function calling, and what is this? This is a function definition. Okay, so this is the last type. Without argument, that means you are not passing. With return, that means you are returning integer value. That's why the return data type is integer. That's it. Thank you very much.